Hello everyone, this is Professor Robert Solis. Welcome to this video lesson. First of all, let me apologize. I am suffering from the bronchitis and the tail ends of it, and so it's had an effect on my voice. So you may hear my voice sound a little coarse or hoarse, and sometimes even just go out if I speak too loudly. So just like right now, what happened. So I'm trying to step close to the microphone so that you guys can hear me clearly. But this is important enough for me to communicate the information to you so that you can get this information as quickly as possible. Okay, so what we're going to do is talk about the Blackout game that we've created in a previous video lesson, but we're going to be using arrays to solve this problem. So I've created this little presentation. Let me go ahead and get into the presentation mode so I can show you how we're going to solve a problem like this. Okay, well, you know that in the Blackout game we have 9 squares. And in those 9 squares, the goal is to touch them and flip them in such a way as to make them either all red or all white. So since I have a total of 9 of these, I can think of them from a two-dimensional array perspective. And so that's what you see down here. Let's think of this as index 1, 2, and 3 for the columns. Remember, columns stand up and down. Column 2, column 3. And let's think of this 1, 2, and 3 as row 1, row 2, and row 3. So this is a two-dimensional array. And this particular item would be located at row 1, column 1. This one would be at row 2, column 3. Alright, so that's how we're going to create our Blackout game. We're going to use arrays, and we're going to come up with an approach to solving this using two-dimensional arrays that'll be effective and elegant. Okay, what would happen if the user touched the center button? Well, we know for a fact that this center button would swap its color, and since it's red, it would go to white. The button above would go from red to white. The one below, the one to the left, and the one to the right of the center button. So that means that when I click the center button, the one above, below, to the left, and to the right, and the center button are going to swap colors. Now, the problem is when any other button is clicked, there is no such thing as above or to the left if I click this particular button, the upper left-hand corner. Yeah, the button that I pressed is going to change. The button to the right is going to change. The button below is going to change. But there is no button above. There is no button to the left. Let me go back to the previous slide. See, my thinking is, wouldn't that be great if we just came up with an algorithm that said, no matter what button is clicked, the one that's clicked, the one above, below, to the left, and to the right, those are the buttons that are going to be swapping in color. But, now go to the next slide, if the user clicks this button on the upper left-hand corner, well, what do? There is no such thing as a button above or a button to the left. So I've got to think about how to solve this problem. And one way that we can do that is to create these phantom buttons. Now, these buttons are not buttons that I've drawn onto the form. These are buttons that exist in memory. So that way, when I click on this button, I can genuinely say that there is a button above, there's a button to the left, and of course, these are the physical buttons to the right and below and the one that I actually clicked. So that's the way that we're going to create our breakout game, is to create a two-dimensional array, but not just simply consider the 9 physical buttons on our actual form. We're going to create a total of 16 buttons. Well, actually, it's more than that. 1, 2, 3, 4, 5. 5 times 5 is 25 buttons. Because what we're going to do is we're going to create these phantom buttons. These guys are only going to exist in memory. These guys are the ones that we actually dragged and dropped from our toolbox onto our form, and then we're going to give all 25 of these names, and we're going to place them into an array. So that's why you'll notice that I started this button over here at index 1, because I was thinking, well, the one just before it, that's going to have to be index 0, which of course is the first element. So this is a two-dimensional array, starting from 0, 0, going all the way up to 4 rows, 4 columns. I shouldn't say 4 rows, going up to index 4 for a total of 5 rows, because we start counting from 0. Going from 0 to 4 for the 5 columns, starting at 0, ending at 4. So this right here, this is the big takeaway of how we're going to solve creating a game using two-dimensional arrays. And you may be asking, well, why do that? What's the big deal? Let me go back a couple slides. This is the big deal. It would be great to click a button, excuse me, and say, swap the color of the button above, below, to the left, and to the right. Now let me go forward. I click this one over here. Swap the color of the button above, below, to the left, and to the right. I click this button. Swap the color above, below, to the left, and to the right, and of course the one that I selected. So do you see that no matter which one of these 9 buttons I click, I can always use the algorithm, swap the button color above, below, to the left, and to the right, and the one that I just clicked, to any of these 9 buttons by placing these phantom buttons around my 9 game buttons. So one of the things we're going to have to do is we're going to give a naming convention to each of these different buttons. So when I drag and drop these 9 buttons, I'm going to call this guy btn1 underscore 1. That first one right there is going to represent the row. This second one is going to represent the column. So notice over here, row 1, column 3. This guy over here, row 3, column 2. So that's the naming convention we're going to use for these buttons. The reason why I'm going to do that is because if the user clicks this button, I need to know who was clicked. Because if I know who's clicked, then I know the definition of above, I know the definition of below, I know the definition of to the left, and the definition of to the right. So if I build into the name of the button, all I have to do is strip away the btn and strip away everything after the number here, and now I've got the row. I strip away the btn, the number, the underscore, and whatever's left, now I've got the column. So built into the name is the actual location of that button. Once I've got the location, now I know relatively what above, below, left, and to the right is. If I click this guy over here, this is above, below, left, right. If I click this guy over here, this is above, below, left, and to the right. So that's the strategy behind giving the names specifically their row and their column, and I intend later on to strip away the btn, get that number, strip away everything else, get this number. Now I know the row and the column because it's built into the name. Okay, so the swap above, below, left, and right, and the one that was clicked applies to any one of these 9 buttons that I click. So that's why we're going to use this particular approach. As I mentioned to you before, if I click this guy, let's take a look at over here, that's the row, that's the column. I've already built that into the name of this button, so I know who you are. Therefore, I know what is above you, below you. In fact, would you agree that if I take that 3 minus 1 gives me the number below. 3 plus 1 would give me the name above. The 1 plus 1, that's the 2, would give me the button to the right. This number minus 1 would give me the button to the left. So see, I can take these numbers, add 1, subtract 1, and I know now above, below, left, and right. Okay, so that's the end of this presentation. Now I'm going to switch over to the actual program to explain to you how this works out. So the first thing that you're going to do is you're going to drag and drop some buttons. So I just simply went over here to my text box, took a button, dragged and dropped it over here. Now you don't have to do exactly what I did, but if you want to mimic close to what I did, I just changed the back color to red for this particular button. And let's see here, there's no text as you can see. The size, I made them the same, so I actually typed in 75 over here and 75 over here, and so that means that it looks square. It's perfectly square. Then I took that button, copied it, pasted it, and then just simply moved it over really close. In fact, if I zoom in, let me unselect these. If I zoom in, I think there's just simply one dot or one point of spacing in between these. Some of you may say, well, I don't like that. It looks like it has the outward appearance, because these are buttons. It looks like it has the outward appearance of an outline. I think you can change the appearance if you wanted to. Let's see here. Where do I do that? I don't use this feature very often, so I'm forgetting where it's located. Let's see here. Text image, padding. No, it's not it. For color, no, that's not what it is either. Ah, here it is. Flat style, or flat appearance, or flat style. This says standard. See, I have this button selected. So if I click this guy over here and say flat, see how it changes the appearance of the button? Or I could change that to pop-up, or I could change that to whatever I want. So in this case, I'll just leave it standard. If you wanted to, you could change the appearance of this using this flat style. Okay, so I have these buttons. I copy and paste these, and then I selected these three and copy and paste them and move them all into position. Let's go over the naming convention of these. So I'm going to select this one over here. Notice that the name of this guy is btn1_1. This is row 1, column 1, just like our PowerPoint presentation. This guy over here is row 1, column 2. Row 1, column 3. See this? This is row 2, column 1. Row 2, column 2, row 2, column 3. Finally, this is row 3, column 1, row 3, column 2, row 3, column 3. So I've implemented the naming convention that I just spoke of in the presentation. With this button, I'm going to call that BTN Reset. I have a label over here that I'm going to call LBL Moves that's going to keep track of the number of times I've been clicking any one of these buttons. So first let me play the game so I can show you what it looks like, and then we'll take a look at the code. So I'm building it now. All right. First of all, when the program starts, notice that there is a random setup that is given to me. If I don't like this, I can just simply click on Reset. Sorry about that. Let me get a drink here real fast. Okay, let me click on Reset again, and again, and again. So the cool thing is, anytime I click Reset, or anytime I start the program, a random appearance, and look at that, it actually gave me a solution, a random appearance of red and white chips, or buttons in this case, is going to appear. Now, first of all, I want to make sure to test that every time I click a button, this button is going to swap, and any adjacent button as well. So I'll click this guy. Yep. I'm going to click each of the buttons twice, just to make sure that we're getting the effect of swapping, as I just mentioned. Looks good. And by the way, the moves counter keeps on incrementing as well. Let's see what happens when I solve the puzzle. Wow, look at that. I just happened to reset and have this one. So one click and we're going to solve this. One click, all of them are white. Now, all of the buttons should be disabled, and I should not be able to continue playing this game. Let's see what happens. Yep, that's right. This game is disabled because I've won. The only way to play a new game is to click Reset. Now I can play a new game. Okay, so let's try this out. Okay, took me 8 moves. Let me see what happens when I click the buttons. Perfect. They are all disabled. I cannot go from here. The only way to play a new game is to click reset. Okay? So that's no big deal. You've seen this game before in a previous lecture. The difference is now we're going to use arrays to solve how to play this game. So let me go ahead and get rid of the toolbox. I'm going to get rid of the properties panel, and let's switch over here to the code. Okay, the first thing that I'm going to talk about is the declaration of a two-dimensional array. Well, in order to declare a two-dimensional array, we're simply going to create, and that is a two-dimensional array of buttons in this case. So what we're going to do is we're going to type the word button, open and close, square bracket with a comma in between. So that indicates this is a multi-dimensional array that we're creating. What are we going to call this thing? We're going to call it game buttons. In order to create this two-dimensional array of buttons, we're going to say this is going to be assigned new button, and then you're going to tell me how many rows and how many columns for the button, for the array, for the row and columns of buttons. Now, that is something that we have created up here. So you'll notice the two constants that I've declared. Both of them are of size 5 for the row size and also for the column size. And that's going to go along with what I demonstrated over here in our presentation. I have 5 rows and I have 5 columns. The first row is going to be index 0. The last row is going to be index 4. Same thing for the columns. The first column is going to be index 0. The last column is going to be index 4. Okay, so I use those two constants here to declare our two-dimensional array of buttons. And then I'm also going to create a moves variable that's going to keep track of the number of moves that I've taken so far to try to solve the game. All right, well, let me see here. I think in the previous program I created a game setup function, so let's take a look at that guy. I don't think anything has really changed. Yeah, so game setup, well, actually, I shouldn't say anything has changed. Something has definitely changed. We're using arrays. And since we are using arrays, I had better go through 2 for loops, one to deal with all the rows, one to deal with all the columns, and then I can randomly swap between red and white. Based on what? Well, I'm going to create these two variables, lower bound and upper bound. And the reason why is for my random number generator, which I've just created right here. So this thing generates random numbers. What I want to do is I want to get like a heads tails type of situation going on. If I get heads, let's make it white. If I get tails, let's make the button red. Something like that. But obviously I can't flip a coin. But what I can do is I can generate two numbers, 0 or 1. And maybe let 0 be the same thing as heads, 1 be the same thing as tails. I mean, conceptually, that is. Well, what I'm going to do is I'm going to create a random number generator. With that random number generator, the .next allows me to create a range of numbers, starting from the lower bound, going all the way up to, but excluding the upper bound. So in other words, this first number is inclusive, this second number is exclusive. So in other words, including this number, going all the way up to, but not including the second number. And that's why you see that I did the +1. See, I want to go from 0 up to and including the number 1. But I'm telling you that .next for the random number generator is deliberately excluding this number. So now that I know how it works, I'll just say, okay, fine. Whatever that upper bound is, I'll go +1. Now check this out. So this is going to be 0. This is going to be 2, right? So the 1 + 1 is 2. So now this thing reads as follows. Generate a random number from 0 all the way up to, but not including 2. Well, that would mean up to the number 1. So in other words, this thing is going to generate either a 1 or a 0. Now, if you happen to generate a 0, then make this button at this particular position in my two-dimensional array, make its back color white. Otherwise, make its back color red. Well, what button am I talking about? I'm talking about the button at row and at column. See, what happens is this outer for loop is generating numbers from 0 all the way up to a number less than the row size. Well, let's see, what was the row size again? I think it was 5, wasn't it? Yep, it's 5. So now this thing is generating a number from 0 to 4. This inner for loop is going to be generating a number from 0 all the way up to 4. Because remember, column size is 5. So that means from 0 to 4, which is 0, 1, 2, 3, 4, that's 5 items. And we're going to increment them one by one. So you can think about this outer loop generating an inner loop, which is then going to say, okay, this button over here in this particular array, well, first of all, let's enable it. Make sure that it's able to be clicked. Then let's change its color randomly to either white or red based on this number, random number generation. And you'll notice that for row 0, we take care of the buttons at column 0, 1, 2, 3, 4. Then we go to row 1, and then column 0, 1, 2, 3, 4. And then we go to row 2, column 0, 1, 2, 3, 4. So if I go back over here, so let's see here, it says starting at row 0 and then all the columns. So starting at row 0, change this color, this color, this color, this color, this color, randomly. Then go to the next row and do the same thing, randomly change all these. Then go to the next row and then randomly change all these. Now, to be quite honest with you, I really don't care about the random color selection for these outer phantom buttons. I really only care about them for the inner game buttons, but that's okay. I mean, it's only going to take, I don't know, a nanosecond or a picosecond to change these outer button colors, so that's okay. We can get away with it. Next thing we do, we set the moves to 0, LBL moves.text. We're going to take whatever that moves value is and put that to the label, which means, in other words, we're updating this guy right here. That's the LBL moves. So we're going to update that. That is the game setup. Well, once I have game setup, then I can say, okay, let's double click on this form, and that's going to take me to form load, and I can actually call game setup so that it can do its job. Here it is. But whoa, there's a whole lot more stuff going on over here when I first load the form. What are we doing? Well, let's take a look here. You know that you have actually given names to these buttons. For example, this button over here, you gave it the name btn1_1. This one you gave 1_2, and so forth and so on. Okay, so what I need to do is I need to say, take this button and assign it into the array position game buttons 1_1. See, this is a two-dimensional array that you created. I want you to put this button into the 1, 1 location. I want you to put this, I want you to put this button into the 1, 1 location, row 1, 1. Put this button, which is this one over here, that's 1, 2, so that's this guy right here. See, 1, 2. I want you to put this button into this array, two-dimensional array location, and so forth and so on. So in other words, I'm populating the array with these 9 game buttons. These 9 game buttons, we're going to put them into the array at these specific locations. So I'm doing that when I first load the program. Now that I've done that, I need to instantiate the remaining phantom buttons. So those phantom buttons, those are these guys right here, these outer perimeter buttons. Okay, so now that means that this button at 0, 0 in my two-dimensional array, which is this guy right here, I need that to be a new button. Now this is a creation of a two-dimensional array over here. This is the creation of a two-dimensional array that holds buttons. But just because it holds buttons doesn't mean that there isn't actually a current button in there. It just holds buttons. See, that's what this thing does. It holds an array of buttons. What this thing actually does, the word instantiate means to create. This creates and places a new button in this specific location of our two-dimensional array. We are going to put a new button here. We are now going to put another button at 0, 1 here. We're going to put another button in here. So in other words, you can think of these as empty containers. You've got to actually put stuff in those containers. And in this case, what do you put into those locations? Buttons, new buttons. So this chunk of code right here is placing buttons into all of these locations. So that's what this does. Okay, so now our two-dimensional array has been populated with a bunch of buttons. Well, now that it's been populated with a bunch of buttons, what I want to do is I want all of those buttons to refer to the same function to all that, so that's when the user touches one of these 9 game buttons, it goes to the same function. Let me show you what I'm talking about. You know that when I click on the reset button, it's going to take me to this procedure called btn reset underscore click, and it's going to execute whatever the code is in here. I do not want you to double click this, double click this, double click this. I don't want you to double click these because it's going to take you into 9 separate functions, as we've seen when we worked on this game in a previous video lesson. That's not what I want. I want the clicking of any of these 9 buttons to go to one specific function. So the question is then, how do you do that? You already know when you double click a button, watch. It's going to take you to a function for that specific button. What are you going to do now if you don't want the double clicking of these to go to a specific function so you can type in code? You want these to go to a specific function. In fact, all the same function. So this is how you do it. Right here. You say, all right, for this button located at this specific row and this specific column, which are going to be given to you by this for statement and this for statement, this nested for statement. So this is going to generate a row. This is going to generate a column. For the button inside of this two-dimensional array, it's dot click member. I want you to refer to a specific event handler called btn array click. Now that sounds like, fancy schmancy language. So you don't even really have to understand the nuance of how this works. All you have to understand is this. I want the clicking of any of these buttons to go to a specific function. Here's the specific function right here. btn click, btn array click. See the function over here? I just created this. I actually typed all this right here. I want you, game buttons, when you are clicked, to go here. So that's why within a for loop for every single row, every single column, in my two-dimensional array, here it is, for your dot click member, go to this function, which I've created down here. Let's see what the comment says. It says, wired this button's click event to a common click subroutine. So again, you don't have to memorize this. I certainly don't memorize this. I just simply go back to my notes and say, okay, I want these buttons to go to a specific function. How do I do that? And then I just look at my notes and I see this and I say, oh, okay, so whatever the array is that contains my buttons, dot click, which refers to the event of that particular button, plus equals, and then this is just simply saying this is equal to, or this is going to be assigned to this, and we're going to concatenate that. Excuse me. We're going to add that to this new event handler, btn array click. So this is what you would need to type to be able to go to a specific function. Well, I better create that function, and here it is. So you're actually going to have to type private void btn array click. Make sure the spelling and the capitalization is exactly as you see over here. Type in object sender, comma, event args e. Interesting. Let's see what happens here when I double click on this. Did you see what I did? Did that kind of fast. I double clicked on the reset button. Private void object sender, comma, event arguments e. Now let me go back over here to the form load. Look at that. Object sender, event arguments e, private void, and then whatever the name of the function is. In other words, you're typing the same thing that is automatically created when the user double clicks, or not when the user, rather when the programmer double clicks on a button, takes them to an event procedure. You're doing the same thing, you're just typing it out. Now the cool thing about what you've just done is by saying all of you game buttons, when the user clicks on you, go to this function. So all 9 buttons are going to go to this one function, and not to 9 separate functions. So what are we going to do in this particular function? Well, when a button is clicked, we know that we have to change the color of the button that was clicked, the one above, below, to the left, and to the right. Okay, so in order to get ready for that, I need to know what is the definition of above, below, left, and right. In order to understand the definitions of above, below, left, and right, I'm going to create a string. I'm going to create a row and a column variable, 2 variables, both of type integer. And then what I'm going to do is this. Okay, the button that was sent to me, see, when I click one of these buttons, it's going to know who it is. Who's the sender? Was it this guy over here, btn11, or was it btn33? Right, just to remind you. See, btn3_3, or this guy over here, btn1_1. Okay. So who sent me, or who is the sender? Who's the one who was clicked? Because I know who you are. Are you btn1_1 or btn1_3? So what I'll do is this. First of all, let me get your name. And the way that we do that is as follows. Whoever was clicked, we're going to get the .name property, and we're going to put that into temp string. So in other words, this is going to be something like, if for example btn1_1 was clicked, this guy is now going to be the string btn1_1. So in other words, you are grabbing the name of the button that was clicked, and we're going to put that into a string variable. Well, now that I've got that, let me get this number right here. What does that represent? The row. Then I'll get this number over here. What does that number represent? Ah, the column. So how do I get this? Let's see here. This B is at position 0. In fact, let me just do this. Let me put a couple comments over here to help you identify what this looks like. Whoops. I'm going to put a 0, 1, 2, 3, 4, 5. That B is located at index 0. that T is located at index 1. Where is the row located? Can you see how it's located here at index 3? Do you see how the column, that one right there, is located at index 5? That's what this is all about. So, I'm going to take this string. I just want this guy right here, and I just want one character. If I wanted these three, I'd say starting from position 0, give me the next 3 characters. But I'm going to do this. Starting at position 3, give me just one character. Then I'll say, starting at index 5, give me just one character, and then that will give me the column. And so that's what this line represents. So we use substring, which is another word for strip away everything except for starting at this particular index and how many characters I want to grab. So let's get the string. I want a chunk of that string starting at position index 3 and only give me one character. Okay, there you go, one character. If this were the number 3, that would mean from the string, get a chunk of it, starting from position 3 and give me 3 characters. Starting at position 3, 1, 2, 3, give me 3 characters. It would give you that. But I don't want 3 characters. I just want 1. So I change that to 1 and it says just get this guy right here. For this one over here, for column, it says give me a chunk of the string starting at 5. I just want 1 character. Starting at 5, I just want that 1 character. Okay. So now you see from the name, the sender, I know now the row and the column. Well, if I know the row and the column, that means I know the button that needs to be swapped. So I have a swap function. I'll take a look at that in just a second. The swap just simply changes white to red, red to white. I'm going to change this button's color. I'm going to change the one above, the one below, the one to the left, and the one to the right. Recall that if this button was clicked, that is at row 1. Well, the one above it is at row 2. The one below it is at row 0. For this button, the one to the right, because we are currently at column 1, the one to the right is at column 2. The one to the left is at column 1. So do you see how I just did this? Took this number plus 1 to go to the right, minus 1 to go to the left. Take this number plus 1 to go above, subtract 1 to go below. Okay, so in code, that's exactly why you see these plus 1, minus 1 operations against the row and the column to move above, below, to the left, and to the right. Finally, after we've swapped the button colors from red to white or white to red, we increment the moves, and then we display that, or we update the label to indicate what the moves counter is now. So this label down here, that is going to be reflecting the latest and greatest change. And then you'll see that there is a function call to check for win. So checking for win just simply means, are all the button colors the same? Are all button colors the same? Well, let's assume that they are. Okay, so I'm going to set this equal to true. I'm going to go through every single row and every single column for the game buttons. Do you see how I start at 1 and I go to 5, which is what this is, minus 1. So I go from 1 to 3 because row is less than 4, so in other words from 1 to 3. Same thing for the column. Go through the first and third columns, the first and third row, so that means just these game buttons. Alright, go through every one of those game buttons and check to see if they're all the same color. Okay, so let's see here. So you know that row is going to be 1, column is going to be 1. So at first this will be game button 1, 1, which will be this guy right here at 1, 1. Is its back color the same as game button 1, 1? Oh, so it looks like I'm checking everything with this guy. So is this the same as this? Is this the same as this? Is this the same as this? So forth and so on. I'm checking everything against the button at 1, 1. So if it's the same, then we'll say, okay, so are all button colors the same? I'm going to use the AND operator with true. So the way that the AND operator works, as you've recalled from past video lessons, is the only way that the left and the right-hand side are going to make this whole operation true is if this is true and this is true. If one of the sides is false, the whole thing is false. So this is a trick. This is a way of saying, okay, I'm going to compare it to all the buttons, and if one of these buttons is the wrong color, this will be false. False and anything is false, so this will propagate false throughout all of the looping. Same thing over here, right, for the else statement. So I'm just trying to find out, hey, are all of you the same color? Because if you are all of the same color, then disable all the buttons because you won. You won the game, disable all the buttons. How will I disable all the buttons? 2 nested for loops going through every single row and column, disabling all of the buttons. How will I enable all of the buttons? Nested for statements going through every single row, every column, enabling all of the buttons. Okay, so that's how those chunks of code work. Let's take a look at swap. Now you'll notice the word ref here. That means that when I pass a parameter to this function, I am passing the original value. That's what by reference means. Give me the original. Pretend I had 2 frisbees. I make a copy of the frisbee. I keep the original and I throw you the copy. That's passed by value. Okay, let's play frisbee again. I have a frisbee and I throw it to you. I've given you the original. That's what pass by reference is. You have the original, which means if you change that frisbee in some way, you've changed the original. And that's what I'm doing here. I'm passing the button originally. Now, you may think, well, Professor Solis, why are you doing that? Okay, let's say that this is the button that's red and I need to change it to white. So I make a copy of this button and I give it to you. Okay, I give you this button. If you change that button and you're changing the copy, are you changing the original? No. If I give you red and you change that red to white, the copy of it, well, this one's still red. This is the original. So what do I have to do in order for you to change the original? I've got to give it to you. And so that's what this means. Give me the original. I will change the background color of the original button that you gave to me from red to white, or if it's white, I'll change it to red. And so that's what this does. So that's why we use reference, pass by reference, is because that means I need the original button so I can change it. So do you see over here where it says the word ref? I also have to use it over here when I call the function. Call the function, I am passing this button to you by reference. You are receiving it by reference. So in other words, I am giving you the original. You are changing the original. And I think that's it. So let's see here. Let me just kind of go through the code here to make sure that I've covered everything. So we have global declarations. If the user clicks the reset button, they're going to call the game setup function because that's going to set up everything. When I first load the program, let's get all these phantom buttons, right? Let's get all those phantom buttons and also the real buttons as well, and put them into the 2-dimensional array. So I'm assigning them one by one. First the 9 game buttons, and then the phantom buttons. Then I'm going to go through every single one of these buttons, and I'm going to say, hey, by the way, any of these buttons from the array that are clicked, go to this specific function. This specific function is going to say, well, first of all, sender is the person who was called btn11, btn33. This is the one who is doing the calling. What is your name? btn11. Okay, I'm going to get the one over here and this one over here to get the row and the column. Once I know the row and the column, now I can define what is above, below, left, and right. And I can call the appropriate swap function with the appropriate button. Increment the moves counter, check for win. Swap, we just went over that. goes from red to white, white to red. Game setup sets up the game. Create a random number generator. Generate a random number from this lower bound to the upper bound. We talked about the idea of exclusion and inclusion. Within this nested for loop statement, you are going to generate a random color, whether it's white or red, and then you're going to assign it to this particular button. We're going to set the moves to 0 because we've just set up the game. And then we have the check win function to check to say, hey, are all of you the same as the game button 1-1 in this location? Put another way, are you the same as this guy? How about you? Are you the same as this guy? We're comparing everything to this. If all of these buttons are the same as this, then they're all the same color, therefore I have 1. If I have 1 because they're all the same color, disable the buttons. How do I disable the buttons? Within a nested for loop statement, I call every single button in my two-dimensional array and I set the enabled property to false. How do I disable? That's disable the buttons. How do I enable all the buttons? Same thing. I just set the enabled property to true. And that's it. So this is Professor Robert Solis. I hope this video lesson was helpful. Sorry again for my voice. Have a good day. See you next time.